Okay, let us look at the second type of problems that you have in search chapter of Hall and Knight. These problems are about finding a factor which can rationalize the third quantity. So for example, you have been given the third quantity which is the sixth root of 5 plus cube root of 2. So we want to find out what should be another third quantity which we should multiply this quantity with so that the product is completely rational, right? So if I write this number as, suppose if I say that this fifth root of 6 is a and this is b, so this is a plus b. Now I want to find some factor so that after multiplying, whatever product I get, the product should be rational. Okay, so this is our aim in all these problems. So we have to find what is this missing. So you have to find this missing factor. Okay, so there is a technique to do all these kind of problems. So all we have to do is first realize a few important properties of some of the factorization, right? So for example, if you have something like, suppose I have a to the power n minus b to the power n, right? Suppose I have something like this, and I'm saying that if n is even, right? So you have something like a to the power 6 minus b to the power 6. Now you will realize that this a to the power 6 minus b to the power 6 is divisible by, this is divisible by a minus b as well as a plus b. Okay, so any factor which is of the form a to the power n minus b to the power n, if n is even, it is always divisible by a minus b as well as a plus b. But if n is odd, for example, you have something like a to the power 9 minus b to the power 9. In this case, it is divisible by a minus b only. Okay, it will not be divisible by a plus b. Now if you have something like a to the power n plus b to the power n, now if n is even, then not divisible by a minus b as well as a plus b. So it is not divisible by a minus b and a plus b. However, if n is odd, say for example, if this was a to the power 10 plus b to the power 10, so we can see that this will not be divisible by a minus b as well as a plus b. However, if n is odd, something like a to the power 5 plus b to the power 5, right? In this case, it is divisible by a plus b. And all of this can be proven using the remainder factor theorem, but because we have not done yet remainder factor theorem, so I would simply want you to remember this, right? Out of this is completely unimportant case for us, so we'll ignore this, right? But we have to realize that if we are only going to find out what should be the rationalizing factor, you would be given something plus something or something minus something. And in each case, we can form the rationalizing factor as a to the power n minus b to the power n or a to the power n plus b to the power n, right? So we can always find what the rationalizing factor is. So let us look at some examples. So in this case, our a is, so we know that our a is 5 to the power 1 by 6 and our b is 2 to the power 1 by 3, right? To find what should be the product, so we are concerned about the product right now, right? To find what should be the product, let us consider what is the LCM of 3 and 6. LCM of 3 and 6 is 6, right? So I know that if I consider a to the power n, that's a to the power, let us say that 6 is equal to n. So if I consider a to the power n, then it is simply 5, which is rational. If I consider b to the power n, then it is simply b to the power 6 is going to be 2 to the power 2, which is 4, which is also rational, right? So we know that a to the power n is 5 to the power 1 by 6. 2 to the power 6 is going to be 5, and b to the power n is going to be 2 to the power 1 by 3 to the power 6 is going to be 4. And a to the power n and b to the power n are both rational. So we have been given a plus b. We have to find the missing factor, but we know that a to the power n, which is 5, and b to the power n, which is 4. Now we have to simply decide whether we should put a minus sign here or a plus sign here. And for that one, you can simply go and look what we discussed. We discussed that if a to the power n minus b to the power n, and if n is even, then a to the power 6 minus b to the power 6 is divisible by a minus b as well as a plus b, right? So we have a plus b already over here. This is a to the power 6 and b to the power 6. So if I put minus sign here, I know that a to the power 6 and b to the power 6 is actually divisible by a plus b. So what we have to do is we have to simply find what is, this is a to the power 6 to the power b to the power 6. So we have to simplify what is the missing factor. So you have to simply divide a to the power 6 by a plus b, and it is easy to see that it is going to be a to the power 5. So you have got a to the power 6 plus b a to the power 5, and we have to cancel b a to the power 5. So we can put a minus sign here, and we can multiply a to the power 4 times b. So this will cancel b a to the power 5. So you have now minus a to the power 5 minus a to the power 4 b square, and we have to cancel minus a to the power b square. So we put plus sign here, and we write plus a cube b square, and we continue this pattern. So we put minus sign a square b 1 plus a b square, this should be b cube, plus a b 4, and finally you have minus b to the power 5. So if you multiply with this factor, which is a to the power 5 minus a to the power 4b plus a cube b square minus a square b cube plus ab to the power 4 minus b to the power 5, you will get a to the power 6 minus b to the power 6, which is 5 minus 4 is equal to 1. So what is a to the power 5? So missing factor is simply, you have to now put values. A to the power 5 is 5 to the power 5 by 6, right? What is a to the power minus 4? It is 5 to the power 4 by 6, which is 5 to the power 2 by 3, times b, which is 2 to the power 1 by 3, plus a cube, which is 5 to the power 1 by 2, times b squared, which is 2 to the power 2 by 3, minus a square b cube. So you have 5 to the power 1 by 3, b cube is 2 plus ab cube, so we have 5 to the power 1 by 6, and b to the power 4 is 2 to the power 4 by 3 minus b to the power 5, which is 2 to the power 5 by 3. So this is the rationalizing factor. Okay, so this is the rationalizing factor. Now let's look at the next example. Over here you have been given 3 to the power, this is equal to 3 to the power 1 by 3 minus 1. So again, let us say that this is A and this is B. So you have got A minus B. We have to find the missing rationalizing factor, but the product should be rational. So what is the LCM of 1 to the power 1 can be written as 1 to the power 1 by 1. So what is the LCM of 1 and 3? LCM of 1 and 3 is equal to 3, and let us say that this is equal to n. So what is a to the power n? So a to the power n is 3 to the power 1 by 3 to the power 3, which is actually 3. And what is b to the power n? It is 1 to the power 3, which is 1. So a to the power n is also rational, b to the power n is also rational. So we write it as a to the power n and b to the power n, which is 3 and 1. Now we have to think about what sign should we put here, because it is a to the power n minus b to the power n, or whether it should be a to the power n plus b to the power n. Now we know that a to the power n is actually, so let us cancel this. Let us write this as a to the power cube, that is n is actually a cube minus b cube, right? And this is 3 minus 1, which is what? Which is 2. Now a cube minus b cube, which is an odd number, is always divisible by a minus b, just like we discussed here, right? If n is odd, then this is divisible by a minus b. So all we have to do is, what should be the missing factor? Simply divide a cube minus b cube by a minus b, and you will get this as a square plus ab plus b square, right? So what is your missing rationalizing factor? It is simply a square, which is 3 to the power 2 by 3 plus a times b, which is 3 to the power 1 by 3 plus b square, which is 1, and that's it. Now let us look at last example of this kind, which is 5 to the power, you have 5 to the power 1 by 3 minus 3 to the power 1 by 4, right? So let us say that this is a and this is b. So we already have a minus b. We have to find what is the missing rationalizing factor. What is the LCM of 3 and 4? So n is equal to, LCM of 3 and 4 is simply 12. So what is a to the power 12? A to the power 12 is 5 to the power 4, right? Which is going to be 625, and b to the power 12 is 3 to the power 3, which is going to be 27. So we know that both a and b are rational. So we know that a to the power 12 and b to the power 12, let us think about what should we put, whether we should put plus sign here or minus sign here. See, a to the power 12 plus b to the power 12 is not divisible by either a minus b or a plus b. So if we put minus sign, we know that this is going to be divisible by a minus b, and this is going to be 625 minus 27, which is a rational number, but we need not calculate it. We have to simply find out what is this missing factor. This missing factor is going to be a to the power 11, so you get a to the power 12 minus b to the power minus b times a to the power 11, so you have to cancel that. So you put plus a to the power 10, so you get times b. Then you can see that minus b a to the power 11 is now cancelled by a to the power 11 times b. So you put plus a to the power 9 b squared plus a to the power 8 b cube. All the way, will not do the entire thing. We'll finally have b to the power 11, and your rationalizing factor is simply going to be a to the power 11, which is 5 to the power 11 by 3, plus a to the power 10, which is going to be 5 to the power 10 by 3, times b, which is 3 to the power 1 by 4, plus a to the power 9, which is going to be 5 to the power 3 times b square, which is going to be 3 to the power 1 by 2, plus a to the power 8, which is going to be 5 to the power 8 by 3 times b cube, which is b to the 3 to the power 3 by 4, and all the way till b to the power 11, which is going to be 3 to the power 11 by 4. So this is your rationalizing factor.